In question 28, we're starting to look at a problem relating some real-world data. We're looking at the amount spent on fast food versus the body mass index, which can be used as a measure of obesity. Now, what I've done here, I've just used a bit of graph paper. We clearly don't have any BMI figure under 10, so I've staggered my axis and then scaled it through to 40, which covers $32 is the highest figure, I should say, and I've gone up to 40 for my BMI. So I've prepared the scatter plot. I'm going to use calculator regression now to find the line of best fit. So if we do that, entering the data, calc, regression, linear regression, as I said before, copy the formula, and we end up with y is equal to 0.53x plus 18.23. I'm not certain if I need it yet, but I'll write these figures down. R squared, 6201. Now, clearly the question isn't in terms of y and x, so I'll put b is equal to 0.53f, or amount, could have used amount I suppose, plus 18.23. The rest of the question gets you to work through and check your figures against the various calculator ones. Now expect the calculator regression to give you by far the most accurate ones, but I'll just quickly work through a couple with you. So in the case of B, plugging through, working up about $35. So when F is 25, B is going to be 35 units. For C, $15. You can see the $15 reading across. It's going to be the order of $27. Oh, sorry, 27 units for my B. For D, $7. Reading through to around about 23. I'll say 23. Now, if we use our calculator to check those, which I'll do in a minute, we'll see how we go. So in the first instance for B, B is equal to 0.53 times 25 plus 18.23. Let's use my real calculator off to the side in this case. It's much easier. And I get 31.48, which isn't too far out from my actual prediction. Please notice when I do things on the graph, it will be a prediction only. I could have tweaked that a little bit, moved my graph down like so, and read it off a little bit better, I suppose. Now, please take your time to check through the rest of those. Also notice that all of these predictions are from within the data. We didn't go outside the data and maybe predict for $40 expenditure, or we didn't have the provision, or perhaps even 35, because we'd be extrapolating beyond the given data. They tend to be less accurate.